When we order food from apps like Swiggy or Zomato, we have so many different payment method options. We have UPI, we have credit cards, we have net banking, wallets, pay later, and so on. The underlying food ordering process does not change much, but the payment methods keep updating from time to time. I always wonder how they do that so easily. Do you? Hello engineers, welcome back. In this video, we're going to talk about the second principle in Solid, which is called the open-closed principle. I hope you're ready. Let's get started. So as per the definition, software entities should be open for extension but closed for modification. So this is true for many scenarios, and one of the great examples I feel is the USB ports that we have on our computers. So you might have seen so many different ports attached to your computer, right? There is USB ports, there's headset jacks, there are mini USB, Type A, Type C, there's HDMI port, Ethernet port, and so on. So what are these ports doing? They're not changing the underlying operating system or hardware implementations. All they're doing is adding more functionality to the existing computer, right? So if you look at this picture, so we have a computer here and it is connected through wires to a keyboard, to a mouse, to speakers, to a webcam, and so on. So all these peripherals are adding additional functionality to our computer without changing the underlying operating system. We are not changing the hardware implementation. We are not changing the operating system style. All we are doing is attaching more stuff so that we can add more functionality and make more use of the operating system and the computer so that we can get more stuff done. So that is the core idea behind this open closed principle. Entities should be open for extension but closed for modification. So let's have a look at the code and understand how to implement this open closed principle, right? So I have a new folder called open closed principle and we have two files, concept and use case. By the way, all this code is available on GitHub and the link is available in the description below, so do check it out. So we have the concept file where we'll try to understand the concept using a familiar or relatable example. And then we have the use case file where we will see a real world implementation of this principle, right? So let's say we have a class called USB device manager, which has just one method, which is called connect device. And it takes in the device as a string parameter. And if the device is a keyboard, we are doing some operation. In this case, we are just printing that it is connecting to a keyboard. If it is connected to a mouse, we are printing that it is connecting to a mouse. So when I run this code, you will see we get two outputs, connecting a keyboard and connecting a mouse. But this is a violation of our open close principle, because if I want to add a third device, let's say I want to add a printer, we would need to modify the existing method. We would need to go into this class and we would need to go into the method, and then we will add a third else if block to accommodate for a printer. That is a clear violation of our open close principle. So how do we fix it? Let's have a look. So we have the same USB device manager class and we have the same method connect device. Now instead of taking the device as a string, we take the device as another object of another class. And what is this class? This class is a USB device class and it has only one abstract method called connect. And this has no implementation, and any peripheral which wants to implement this USB device will have to create a functionality for the connect method. We'll have to implement the connect method. So let's say the keyboard is implementing this USB device class. It will have to create a connect method saying connecting a keyboard. Similarly, a mouse implements a USB device class and it will create a connect method. So this way I'm able to create multiple peripherals without touching the USB device manager class. And all I am doing is passing the mouse object or passing the keyboard object, and USB device manager knows how to handle it. So it will simply call the connect method, right? Now if I do this, I can create a keyboard object, I can create a mouse object and pass them down to my connect device method so that I'm able to use these peripherals. And if I want to create a new peripheral, I can just redo this implementation like this. Let's say I want to create a printer. And just like that, my printer is ready. I am now able to use a printer as well. Let's run this code and see. See, now we have successfully connected 3 things without having to touch the USB device manager class. Now we have made this class so generic that it is able to accommodate multiple devices. In other words, this is now open for extension but closed for modification. We don't need to touch it for anything else. All we need to do is create multiple subclasses for the USB device class and then use them with the USB device manager. Okay, so this is a good example of understanding how open close principle works. Now let's see the use case file. This is a very popular example to understand the open close principle. Let's say we have a payment processor class and it has one method, process payment, and it takes in payment type as the input. And if the payment type is credit card, it will process it by printing it. And if the payment type is PayPal, it will process the same way, right? But this is clearly a violation, because if we want to add a new payment method, we will have to come to this class and to this method and modify this function. This is a violation of the open close principle. So if we run this file, you will see that it still works. But if I want to add a third payment method, we will have to come in, add another else if block to make a new payment method, right? That is a violation. So how do we fix it? Let's have a look. So we have the same payment processor class and we have the same process method, but instead of taking in a string as a payment method, we take an object as a payment method, and it will be of payment method class, right? And what is this payment method class? So this will be an abstract class and it will have a one method for process payment, but it is a virtual method, which means there is no implementation, and anybody can use this abstract class. So credit card can use this abstract class to create its own payment processing method. PayPal can use it for its own processing method, and if I want to add a third payment method for UPI, I can just repeat the process and do so. So if I run this code, we get the same output, but now this is open for modification. So let's add a UPI method. Let's run and see. And just like that, I'm able to add my UPI payment method without having to touch the payment processor class. So that's the whole point behind open close principle. So I hope you have understood the definition and implementation of the open close principle. If you have any questions or suggestions, definitely ask me. Put them in the comments below and I will try to address them. Thank you so much for watching, guys. In the next video, we will tackle the third principle, which is the Liskov substitution principle. So if you haven't subscribed already, do subscribe and share it with your friends. Thank you so much for watching, guys. I will see you in the next one. Cheers.